Hi, this is Mr. Max. I am continuing on the lessons on binomial theorems. But before I continue to the other lesson on binomial theorem, I want to do binomial identities, just to practice our n choose r formula, which you now is n choose r, and that is given as n factorial over r factorial, then n minus r factorial. You can write it in that way as well. Right, so here important, we need to solve for n, and we are told that n is positive. So that means I will have n factorial over 2 factorial, and then I have n minus 2 factorial, and this is simply equal to 15. Nothing you can do on that side, right? What do we know? We know that that n factorial can be written as n minus 1, n minus 2, and that's where I'm going to stop because I see something at the denominator there. So all over, well, 2 factorial and n minus 2 factorial is equal to 15. So we can go ahead and we can cancel out common factors. So what I'm left with is n minus 1 all over 2 times 1. That is what 2 factorial means, and that is equal to 15. So at the end of the day, I have got n minus 1 is equal to 2 times 15 if you sort of cross multiply, or clearing the denominator. Right, so this is where I am. Now, there's an easy way to solve this question. Now, of course, if you look at n, let's say n is equal to 3. So I have 3 and 3 minus 1, looking at the left-hand side. So that's like 3 times 2. So it's like numbers that are going, that are decreasing but sort of follow each other in that order, decreasing by 1. So therefore, I know that 30 is then the same as 6 times 5. All right. So then I can actually find my answer where n is equal to 6, and you get the same answer when you say n minus 1 is equal to 5. Of course, you will see that n is equal to 6. So the answer there is 6. So ideally, if you didn't know, or you don't know, you couldn't do that, then you can go ahead and create the quadratic, and you should be able to solve it. That means from here, you can also say n square minus n is equal to 30. Then you have n square minus n minus 30 is equal to 0. And of course, one bracket will have a positive, one bracket will have a negative, equals to 0 because of that negative constant over there. The number is 5 times 6, going to give you 30. And then you have negative 6 as well as positive 5. If you factorize this quadratic, it should be quite simple and straightforward for you whenever you are doing this course. Then equating that to 0, of course, this gives you n is equal to negative 5, which we are going to reject because we are told that n is positive. Okay, right from the beginning, that our n value is positive, and very important to take note of that. So what are we going to work with? So our answer therefore has to be n minus 6 is equal to 0, where n is equal to 6, which is identical to that other answer over there. All right, let's look at another one. So the second question, using that formula again. All right, so I'm going to say n plus 2 factorial all over 4 factorial over n plus 2, of course now minus 1. Okay, minus 1 factorial. My goodness, minus 1. I said minus 4 factorial. Okay, just want to make sure that we don't miss that. And this is going to be 6, and here is n factorial over 2 factorial, and then n minus 2 factorial. Okay, let's just clean up the left hand side. So the left hand side is n plus 2 factorial over 4 factorial, and then I have n minus 2 factorial over there. Okay, this is equal to 6 numerator times numerator, 6n factorial over 2 factorial, which by the way is just 2, and that's n minus 2. Okay, so 2 factorial is nothing but 2 times 1, which equals to 2. So I'll just go ahead and I will just leave my answer there as 2. Okay, just to make my calculation slightly easier. Okay, so again, you can also then see, okay, what is 4 factorial or 4 factorial, which is like 4 times 3 times 2 times 1. Of course, 4 times 3, that's 12, 12 times 2, so that is 24. So again, I will just rewrite this 4 factorial as nothing but 24. It kind of helped me so that I can see and work on that. So because I'm going to cross multiply for now, and if I do that, I'm going to have 2n plus 2 factorial, okay, and then n minus 2 factorial equals to 24, 24, writing 26, and I'm saying 24, so it's 24 times 6n factorial, and then n minus 2 factorial. Okay, so there are a couple of things that we can do here. Of course, we can divide throughout by n minus 2 because I see that this is a common and that is common. So what is it that we are looking at? Well, of course, it's like I am dividing throughout by n minus 2 factorial, okay? And I'm dividing here also by n minus 2 factorial. Of course, there's also something else I can do. There's a 2 there. So I can also divide by 2, and I divide here by 2, and that gives me 12 over there. Okay, right. So let's see. So we are now at n plus 2 factorial equals to, that is that for the left hand side, 12 times 6n factorial. That's what we have so far. Now let us look at n plus 2 factorial. Of course, n plus 2 factorial is nothing but n plus 2, then n plus 2 minus 1, then n plus 2 minus 2, okay, factorial. And then this equals to 12 times 6n factorial. The reason why I do this, to clean this up, this is n plus 2, that is n plus 1, and this one is just n factorial. Okay, don't have to put it in brackets anyway, you can just write n factorial. That's what I get, and that is equal to 12 times 6n factorial. All right, what does it leave me with? It leaves me with dividing here by n factorial and here by n factorial. When I do that division, okay, when I do that division, well, this cancel and that cancel. So at the end of the day here, I have 12 times 6, and 12 times 6 is nothing but 72, okay? And then on this side, I have n plus 2 as well as n plus 1. Let me just rewrite it nicely. N plus 2 and then n plus 1. So I'm going to use the same type of approach that I had with the question before. So there is a difference of 1 between the two products that will give me 72, because look at that number, n plus 2, the other one is n plus 1. So if n is equal to 11, for example, then it's 11 plus 2, which I clearly know is 13. The other one will be 11 plus 1, which I clearly know is 12. So it's like two numbers that you are looking for, and then decreasing in that fashion. So what could the numbers be? Well, the numbers are nothing but 8 and 9. So 9 being the biggest one. So 72 is 9 times 8. Okay, 9 times 8. So I have n plus 2, n plus 1 is equal to that. Right, so n plus 2 is equal to 9. I'll get the same answer if I say n plus 1 is equal to 8. And you can go ahead and look, so that gives you take away 2, or equals to n equals to, let's see, 8 take away 1. So what is our answer for n? And n is positive. our answer is n is equal to 7. Of course, you'll get the same answer here, n is equal to 7. Right. If you couldn't do this, then I suggest you could also perhaps use the quadratic. So you have n plus 2, n plus 1, that equals to 72, and then you can solve the following quadratic. So of course that is going to be n squared plus n plus 2n plus 2, that is equal to 72. All right, that gives you n squared plus 3n plus 2 minus 72. Well, that gives you 0. This then gives you n squared plus 3n minus 70, that gives you 0. And looking for that number is 10 times 7. The number has to be 10 times 7, with the 10 being positive and the 7 being negative. So 10 is positive and 7 is negative, gives you not. One answer will be n equals to negative 10. So this one we're going to reject it. And the answer that we're going to look at will be the second part, where it is n minus 7 is equal to 0 and n equals to 7, which is the same answer that we got in our previous part. Okay, so that was a short intro just to quickly to two questions. Although it is not in your syllabus AS level in Namibia, okay, and also I don't have to worry about any other thing. I just want you to give you a bit of practice from before I start with my second part video on binomial theorem.